Anyone, if you know, is X, can you say X is a random variable with respect to F? So, okay. So you are given omega, right, as A, B, C, D, A, C, B, C, and D. Okay. And you have a function that maps from omega to say R. I'm keeping the other set to as R, and we can map the relevant points there. Right? So this is a set A, B, C, and D, and this is another. Say this is the entire of R. Right? Within that, you have what you have. So 0.5, 1, and 2, right? Okay. 0.5, right? This thing is mapping to R, and C goes to 1, and D goes to 2. Right. So to answer this, we have to recollect the definition of a random variable. Right. So what is a random variable? It's a function from that takes omega f. This is a kind of measure space with a probability measure, right? Initially, and take this random variable, the function on omega, and it creates. You can think of R and B subscript R. Right? This is Borel sigma algebra generated by the open sets in R, right? So this is what as right. Now to verify something is random variable, right? You should have this set. Set is omega, set of points in your this omega, such that x of omega less than or equal to x. This should belong to F, right? So only then you call this X is measurable, a random variable with respect to this F field F, sigma field F to be specific, right? And this should hold for all X belongs to R, right? So I think we have F to be omega empty set A, B, and C. A, B. Sorry for this bad notation, I think. And set C, comma D. All right. So you can see put X as say 0.75 here. If X is 0.75, what is my set? What is my set? Can anyone type in if you are not willing to speak? If X is 7.5 and this is my X of omega, right? What is this set? Chat, anyone? AB, cool. Yeah, that's right. Because both A and B maps to 1. Sorry, 0.5. So they both satisfy that set, right? And you see if AB is present in F. So it is present in F, right? So it satisfies for this X, 0.75, right? Now let's do something 1. Let's put X is equal to 1. right? What is this set you will get when x is equal to 1? Again, you can chat, type in. Right? If x is equal to 1, what is this set? ABC, that's cool. No, C is not correct, because if you see set of omega such that x of omega is less than or equal to 1, right? C satisfies that one. C is exactly equal to 1. But A and B also satisfy that condition, because A and B map to 0 0.5, 0 0.5 is less than or equal to 1. That is true, right? So A, B, C all belong. A, B, C is this set basically. When you see X as this thing, right? So now what you have is A, B, and you have ABC. Right? This you got by setting to 0.5, and this you got setting to 1. Right? If you set it to 2, you get full omega, right? And if you set something to 0.25, you get an empty set. All right. So this is what you got. Now, if you see ABC should present in F, which is not. Right? So that's why X is not a random. So not a, sorry, it's not a random variable with respect to F. Right? This may be random variable with respect to some other F. I don't know, but for this F, this is not a random variable. Right? So yeah, so you have another follow-up question, which is the minimal sigma field with respect to which x is random variable is this. So basically, you have to see this. Sorry. Yeah, you have to find the sigma field, a minimum sigma field, which contains this all these elements. Right. So that is what I think they have given, and that's the answer. You got it right. Um, yeah, this is I think a little bit involved. This is the only question where it is good to put some thought. I think the rest should be fine for you guys, I hope. So this is second question. You have given same sample space A, B, C, D, and F is again a sigma field defined like this, right? And this is sigma field, right? And P is the function from F to this thing, 0 to 1. Basically a probability measure, right? Defined on the subsets of collection of subsets of F. Here it is defined as F. And here it is defined in a peculiar way, like P of A is 2 over 7, BC is 3 over 7. What is D? Right? Find the value of beta such that P is the probability on omega F. Right? It's a very simple question you may want to try if you want to try without looking to the solution. To be a valid probability space, right, it has to be a non-negative, and P of omega should be 1. Right, and yeah, you have one more constraint, right? If A and B are exclusive, right, P of A union B is P of A plus B. Right, so basically we just need to use the first one. P1 is sample space, entire probability is 1, and that is nothing but union of A, B, C, D. Basically, this is union of this. Can write that right in this way, because these are this thing, right? There's no intersection among these things. You can write down as the sum, and yeah, you just need to 2 by 7 need 2 by 7 to make it to 1. That's it. I hope this is clear, right? This is simple. Any doubts in the chat? Okay, cool. Sorry, no. Okay, so here you have given a random variable x that represents the number of people who arrive in a coffee shop in a day. Some probability density function is given, or mass function because it is discrete. Right? At 5 it is 0.3, at 8 it is 0.2, at 10 it is 0.3, 15 is 0.2. Then which of the following is true? So x less than or equal to 10, right? You have to sum all the probabilities, right? X less than or equal to 10, you have 5, 8, and 10, both on, right? That's why it is 0.8, it's not 0.5. Right? And for these, say, how do you do this kind of things? This is this one, right? X less than or equal to 10, and I'm explaining this this thing, the second point, second solution, correct solution. Let me see, x less than or equal to 10 given x greater than 5. Right. Okay. Probability x less than or equal to 10 given x greater than 5. So, yeah. So this is, you have to take this intersection of two lines, right? AB given B, then that's what I'm using here. X greater than 5 and x less than or equal to 10. This is probability x greater than or equal to 6, right? I can write x greater than 5 is x greater than or equal to 6 as it is discrete. Right? This thing is also 6 is less than or equal to x is less than or equal to 10. Probability x less than or equal to 6. Right? So, yeah. So basically, what you get here is from 6 you have to count the probabilities, right? Basically 6 you don't have, you have to count this thing, right? 0.2 and 0.3, right? Between 6 and 10.5, and x greater than or equal to 6 you have to count all, right? So 0.5 by 0.7. I hope that's clear. Yeah. X being a symbol for a function can explain the meaning of x less than 5. So basically, x is here is a notation of a random variable taking the values right, 5, 8, 10 as basically discrete values, so just a discrete random variable. Okay, so x less than 5 or whatever, greater than 5, whatever you have typed, is x less than 5. The meaning is x can take values up to 4, right? Assuming these x is the discrete valued random variable. right? And you have probability assigned to each of these events. Is it clear? Okay, so um, see, I mean, typically random variables are functions on your underlying probability space, right? But while working, you have to keep in mind that, say, how should I put it? Um, uh, okay, so let me just clarify that uh, here. I think there is some confusion here. So when I say this thing, probability that x is less than 5, right? Right? You have to understand that this is equal to probability of omega such that um, x of omega. So this is a probability on this set, and this set belongs to some f. So let's call this set as f, and this f belongs to some underlying field, sigma field. Got it? I think Rajkiran, right? Okay, cool. So basically, while working, right, we don't go back and see on this f and omega, right? You by definition they specify what is the probability of this kind of structures typically. Then this is what is called exactly as CDF of a random variable, right? So that I mean going to F's and all, it's painful. So typically they measure they specify the CDF and you just work with them. So you have to keep in mind that this is what is happening underlying. Okay. Uh, okay. So okay. So this is, I think, a very standard thing. Omega FP be a probability space. AN is be a non-decreasing sequence of elements in F. Right. Basically, these are elements in F means sets, subsets of omega that are present in F. And these are non-decreasing. That means they are monotonically increasing. You can see. Yeah. Anyways, non-decreasing or monotonically increasing is the same thing. Then which of the following is true? This is a very standard result, right? So continuity of probability, right? You can exchange the limits and the probability. Okay, so this is the answer. You want me to prove it? I can prove it for you now, or you can refer to any of these standard texts. You will know. Let me know if you want me to prove it. That I can write it down. Sure, sure. I'll prove it. Okay, so what is being given as you have a monotonically non-decreasing, that means say given a subset of A2, subset of so on A. Elements in F are sets. Yes, definitely. Every element in F is a subset of omega. Right? That you have to keep in mind. Yeah, so this is subset. Subset is what if A is subset of B, then B is bigger than A. That's how you define for sets. Not less than or greater. Okay, so this is how we are defining the increasing sequence of sets, and for this thing, An is nothing but union of all these Ans up to N, right? For these kind of sets. You guys agree with this? So just imagine that this is A1 is contained in the biggest circle A2, right? Now A2 is nothing but union of A1 and A2. Clear, right? Because this fact we will use repeatedly. So now, okay. So now, this thing, probability of An is equal to probability of union of I is equal to 1 to n. Okay. Right, so far this is clear, that I'm just putting probability measure on these two sets, right, which are equal. Now, the trick here is to create sets which has similar measure as this union of A's, disjoint sets which has similar measure as this guys. Right? Let's call A1 as B1, call B2 as A2 minus A1, call B3 as A3 minus A2, and so on, Bn as An minus An minus 1. Okay, so this is B1, right? B1 is A1, and B2 is nothing but this is B2. That's how I define A2 minus A1. Sets with, points which are in A2 but not in A1. Right? That's what is A2. Okay. So yeah. So if you see here, A1 union A2 is same as B1 union B2, right? So this quantity E of union of I is equal to 1 to n. Sorry, AI is equal to P of union of I is equal to 1 to n bi. Okay, clear so far?
Can you hear me now? I just removed my earphones. Can you hear me? Okay, cool. Yeah. So because these are disjoint sets, right? P of union of B1 to Bn. You can write this as summation I is equal to 1 to n P of Bi. Okay. And one more thing is you are asked this thing, right? Limit n tends to infinity. An, right? This is what is being asked, right? So if I substitute n is equal to infinity, I just write this as union of I is equal to 1 to infinity ai. So by the way, by the definition of sigma fields, which is closed under countable unions, this set also belongs to sigma field. So writing P on this set is perfectly valid. Okay, some minor technical note. Again, this thing you can write it as P of union of all these disjoint BIs, infinity BI, right? So this is equal to sigma I is equal to 1 to infinity P of BI. Okay, so because this is a element of F, P on this exists and this also exists, right? And because this sum is convergent, this series is convergent, right? You can write it like this, limit n tends to infinity, sigma I is equal to 1 to n P of BI. Okay, and what is this thing? This sigma P of BI from this thing, from this line, right? This we can write as uh, this we can write as P of union of all BIs, which is same as union of all AIs, 1 to n AI, right? There is limit n here, okay, always, right? Because, and this quantity is nothing but an as what I defined here. Okay, so here we have this thing, right? Limit n tends to infinity. You started with this thing, P of an is what you got, and you started with this thing, P of limit n tends to infinity an. Okay, that was um, the proof. Is it clear? Okay. Uh, Example, you can cook up any example, but yeah, right now I cannot think of any. Yeah, given a time, I think you should be able to cook up. I can put a slide in the next week's meeting if you want. Is that okay? Okay, so yeah, that was a question, and this is a very simple question. I want you to give an attempt. Right, an urn contains n cards numbered from 1 to n. A card is drawn at random from the urn, and what is the probability that the number on the card is divisible by 3 and 5? Basically, you have 1 to n numbers, right? And you draw a number from them. What is the probability that it is divisible by both 3 and 5? I mean, you can see the answer, and you have to justify uh, why it is the case. Okay, you guys can stay this solution for some more time and think. If you have understood, I'll give a quick explanation and then we'll move on. You have given 1 to n integers and you asked to pick one. What is the probability that it is divisible by both 3 and 5? Okay, so let me give a quick explanation for that as well. Um, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, and you keep on repeating it. Okay, so this. Okay, is it fine now? I have removed my this earphones. They are out of charge. Can you hear me properly now? Yeah, that I understand. Yeah, so yeah, they're out of charge earphones. So I'll try to speak as close as possible. Okay, there will be some noise. Yeah. So, but you can hear me right properly. Okay, cool. Right. So every third number is divisible by 3. Right. And every fifth number is divisible by 5. 10 and this is divisible by 3, and this is divisible by both 3 and 5. Right. So basically 15 is the least common multiple of 3 and 5. Right? That's where you so every 15th will be divisible by both 3 and 5. So basically you have 3 and 5, right? 3 and 5. So I'm writing very vaguely here, right? 3 intersection 5. 3 means divisible by 3, 5 means divisible by 5. So this is P of 3 plus P of 5 minus P of A intersection 3 intersection 5, right? So here there is a meaning to 3 and 5. So here there is a meaning to 3 and 5. Okay, this is not something weird we are doing. 3 is nothing but the probability of the set that is divisible by 3, right? And 5p of 5 is a probability on the set that is divisible by 5, and 3 intersection 5 is a probability you're computing on the set that is divisible by both 3 and 5. Right, out of n you are given n by 3, and right, you are given n by how many? 16, not n by 3, right? So right, out of n, right? So it's force, right? Yeah, you have n over 3, and you have n over 5, and 3 intersection 5. Every 15th is divisible by 3 and 5, right? That's why it is n over 15th. Okay, cool. So is this fine? Can we move on to another question? Is LHS P of A union B, E, A intersection B, right? Both 3 and 5 is, oh, okay, okay. I think 3 or 5. That's a good question. Mm, right. So this is what it is. Yeah, actually, this question should have been 3 or 5, right? So, yeah, this is union. Yeah, if the question was it has to be divisible by both 3 and 5, right? Is n over 15 by 5, right? N is the answer, right? Um, okay, I think that's a good point, right? LHS has to be in B, yeah. A intersection B is trivial. Uh, so I'm moving on to next question if there are no more doubts. Okay, so yeah, so there are 10 independent trials, each of which results in any of 0, 1, and 2 with respective probabilities 0 0.3, 0 0.5, 0 0.2. Okay, so you get any one outcome. In one trial, you get either 0 or 1 or 2. Okay, so then the probability that both outcome 1 and outcome 2 occur at least once, right? So I think this is it's better if we do this on the sheet. Okay, so we are given you're performing 10 trials and you have outcomes 0, which is I'm denoting by A0, and outcome 1, A1, outcome A2. Right, what is being asked here is the probability that both outcome 1 and outcome 2 occur at least once, right? So they want outcome 1 and outcome 2 at least once. So A1 and A2. Let's call this as B. And they want this B. They want this B to happen at least once. Right. So you have 10 trials. You want B to happen at least once. Right. This is nothing but 1 minus, you know, B doesn't happen at all, right? So B complement happens in all the 10 trials, right? Because each trial is independent, right? Um, so 1 minus none of this guys should happen, A1 and A2. What is complement is nothing but A1 complement union A2 complement. Right, so this is P of A1 complement plus P of complement minus P of A1 complement A2 complement. Okay. So what is A1 complement? What is this A1 event A1? A1 is 0.5, right? A1 complement happens with 0.5. So 0.5 power 10 in 10 trials. Plus you have this A2 complement. See what is A2? A2 is 0.2, so 1 minus 0.2 is 0.8 per 10. 0.8 over 10. And I think this A0 is 0.3. A1 doesn't happen and A2 doesn't happen. What does it mean? In 10 trials, A1 should not happen, A2 should not happen. That means only A0 happens for all 10 trials. That's why it is 0.3 power 10. All right, your answer is 1 minus this thing. Okay, clear guys. Um, we can move on to the another question. You can stare at the question and answer, and whatever I explained, you can think about it for a while, and then we can move on to next question. Okay, so I'll move to next question. Uh, yeah, so let me finish this thing, whatever assignment that we are supposed to finish. Um, okay, power of 10, right? So Kaustubh, right? So let me finish this, then I'll try to attempt this question. Okay. Um, so what is the logic behind taking power of 10? So basically A1, this whole experiment is done for 10 trials. Okay. And what is A1 complement? Is A1 should not happen, right? A1 should not happen in all of the 10 trials. So A1 happening probability is 0.5. That's why A1 doesn't have happening probability is also 0.5, and it should not happen for all the 10 trials because they are independent, right? You take uh, this thing A1, each trial is independent, right? For independence, you must be knowing this thing, right? This product of this thing, P of AI is, right? Is that clear thing, Raj Kiran? Right? Is that clear the logic of taking power of 10? If 15 trials, you have to put 15 there. Okay. So I think we will come back to that question, Kaustubh, right? If not, I'll try to answer that next week. So, okay. So here x is again discrete random variable. This is a very simple question, and PMF of x is given by 1 by 2 power k. K is go from 1 to 3. Then phi is less than or equal to x is right. What is the value of the CDF of x? Okay. So CDF of x is nothing but probability x less than or equal to x. Right? Between 5 and 6, what is this value? Right? So if x is phi, right? Fx of phi is probability x less than or equal to phi, right? So you have to sum these probabilities from 1 to 5. That's why fx of x is that. And if it is 6, for any x between 5 and 6, this thing is correct. But once x takes 6, you have to sum up this x value 6 also. K is 1 to 6. This is a simple question. Okay, I'm moving ahead on this thing. This is, yeah, this one is the others. Okay, okay. Any more questions, right? Yeah, so X is random variable with this PDF, and you can see this is a valid CDF. Okay, and you are asked to find each of these quantities, right? So how do you do this? So I'll just explain in principle what to be done. Uh, you can do entirely this thing with just the density function, right? We don't need any other information because it is continuous and all, right? So there won't be any um, issues. So let's do the first thing and also the last thing because that's easier and tricky. Yeah, these are uploaded to YouTube. you can find this. So today is most likely I'll upload it on YouTube by Monday, so you can watch them. Okay, so where we are. Yeah, so x less than or equal to 2 by 3 given x greater than 1 by 2. Okay, let's put this thing. Probability x less than or equal to 2 by 3 given x, what is that? Is greater than 1 by 2, right? Yeah, greater than 1 by 2. Greater than 1 by 2. Okay, so this is what you have to write. Same thing. P of a given b is ab by b. So x less than or equal to 2 by 3 and x greater than 1 by 2 by probability x greater than 1 by 2. It's very simple because we are given the density, right? Fx here. We just have to integrate this thing. Right, this integration goes from 1 by 2 to 2 by 3. 2 by 3. And the bottom one, it goes from 1 by 2 to 1. Fx of x dx. Here fx of x is given as 4x cube. Right, you substitute it. I think you should be able to do this thing easy. Okay, so there was another question, interesting question. X less than or equal to 1 given something. What is that? The last question, greater than 1 by 3. And your density, interestingly, is this thing, is 4x cube from 0 to x, right? And x greater than 1, it is 0. So just by looking at the density, can you tell what is the probability of this thing? Right, it is, your density is only given up to 1, right? So given x less than or equal to 1 is a certain event, right? So this is 1. You don't even need to compute anything. Even if you compute, you'll get 1. Okay, so let's move on to another question. This is also the same thing, simple question. Same thing, a random variable with CDF, where you are given density, here you are given distribution function. What is the probability that you have to compute the probability of so all these events basically. So let's see, let's try to get this 1 by 4 to 3 by 8. So you want probability of y being, this is y, 1 by 4 to 2 by 8 to 3 by 8, right? And this is nothing but density is continuous, right? Then probability of a is less than x is less than b, or whatever, less than or equal to a less than or equal to b, is nothing but fx of b minus fx of a. Okay, so is y square and 1. Your distribution function is something else, y square and then 1. This is 1 by 2. This is 1 by 2, and this 1. And this is f of y. Sorry, actually, this thing. At 1 by 2, this is 1 by 4. Right, at 1 by 2, this is, sorry, this is not how it looks like. This is 1 by 4. 0 to 1 by 2. And then it is 1. Basically, you have a jump at 1 by 2. A jump of 3 by 4, right? 1 minus 1 by 4. All right, so your this 3 by 8 is less than 1 by 2, and 2 by 8 is also less than 1 by 2. So this is continuous within this thing, and we can apply this this formula, right? And let's see what is this thing, a probability y greater than or equal to 1 by 4, right? Yeah, so that is, you can probability y greater than or equal to 1 by 4, you can write it as 1 minus probability y less than or equal to 1 by 4. And at 1 by 4, this is all continuous, and you can still use this thing, because I think y is positive. Again, you can use this same formula, right? Yeah, y is positive, so basically probability 0 is less than y is less than 1 by 4 is f of 1 by 4 minus f of 0. Right, so that is nothing but 1 minus f of 0 is 0, because it starts from that. And this is 1 by 16, and this is nothing but 15 by 16. Okay, so that's what you got. Any questions so far? And these are very simple questions. To do algebra, that's all. I think this is the last question. Consider a random experiment of choosing a point on an annular disk. Annular disk is the region between two circles. Okay. Of radius r1 and radius r2. Right? R1 is less than r, and x be the distance of the point from the center of the annular disk. Then the PDF of x is, and PDF of x is, I think, is not, it's not the, I would say, the right question. This is what you want. If r1 is less than, r1 is equal to 2 and r2 is equal to 10, what is the probability that you pick any point, it falls in this annular region? Okay, let's try to visualize that question. Create. So you have r1, this is r1, and this is your center, and this is r2, this is r2, this is r1. Okay, this is where you are picking the points. Right, so first question, what is given is r1 is 2 and r2 is 10. Okay, r1, this is 2 and this is 10. This radius is 2 and this is 10. What is the probability that you pick a point between, sorry, less than some point is less than 10? I mean, this is one because any point you pick in this angular region is it is between 2 and 10, right? So that's why it is 1. And let's see the another question. What is R1 is 5 and R2 is 10, and what is the probability that you pick a point between 7 and 8? So this is 5. Now in the second question, this is 5. And what is the probability that you pick any point between this, say this is 7 and this is 8, radius of 8, right? What is being asked is what is the probability that you are in this region? Okay. So this is very simple. I mean, here the desired area you have to compute, right? Desired area is pi times your 8 square, the minus 7 square. And the total area that you can sample the point is pi times your 10 square minus 5 square. Right, so this is nothing but above one is 15 times 1, bottom one is 15 times 5. This is equal to 1 over 5. Okay, so this is it. Uh, Chetan is typing. Let's see what this questions. On which YouTube channel we will use this video. So basically, will be a sheet. I think the PMR team would have shared, not PMR. Okay. The NPTEL team would have shared with you guys, right? Uh, so they would have shared a link. There is some public sheet is there, right? So there you can find the link. Is there on the site itself, not the site. So this NPTEL team, they maintain the sheets where they give you all the slides that I'm sharing. Also there will be a link where you can download the slides and the lectures that are posted onto YouTube. Is there on the site itself? Can you suggest a good book to get familiar with the important notations that we will be using? What do you mean by notations? I'm not understanding. Yeah, just for today, you guys bear with me because my charger for this earphones gone. Okay, probability of x less than 5, right? Just any um, should I- okay. I'll give a good reference, Raj Kiran, in next week. Okay. There are too many that are coming to my mind, but yeah, I'll give you one good reference. Okay, so I think there's one question that is being asked, right? Let's go to that question. I think Kaustubh is there in the call. Yeah, I think he's there on the call. So how many people have to be in a room in order that the probability of at least two of them celebrate their birthday in the same month is at least by two. Uh, assumes that all possible monthly outcomes are equally likely. Okay, so let's attempt. Let's see how far we can go. Let's attempt this. Right, probability. So there are n people. Assume that you don't know what is n a priori, and you want probability that at least two of them, right? At least two of n share same birthday in a month. That should be how much? That should be at least 1/2. Okay. Okay, cool. There are two at least. So here we can think of it like, right, one minus probability none of them share none share the birthday in a month. Okay. Um, so what is the probability? So how many total outcomes you have? There are in persons and there are 12 months, right? So okay, on to so here all the persons can also they can have their birthdays in one month, and none of them can also have birthdays in so you can have this person one, person two, and so on, person n. Okay, here the person one can have birthday in any of these 12 months. 12, right? Person 2 can have birthdays in any of these 12 months, and so on. Okay, so here you have 12 per n that is going up, right? And none of them are having birthdays in this many, what should I say, in this 12 months, right? So here person 1 can have any one of the months in 11 ways, person 12 ways, and person 2 can have in the remaining 11, and so on. And how many? Say, it depends on n how far you go, right? So here it is 12. Sorry, this thing I'm rewriting 12 times 12 minus 1 times 12 minus 2. This is for person 1. So on you can get 12 minus n minus 1 in general, right? So this is your desired probability 1 minus 12 minus n plus 1. This is a product actually, okay? 12 into 11 into and so on up to this point, okay? This divided by 12 per n needs to be at least 1/2. Okay, you solve for n, whichever n is the largest that satisfies this equation, that is the answer. Kaustuv, is that clear how to attempt this problem at least? 12 minus n plus 1 part, right? Okay, so first First guy can say if you have only 12%, 12%, right? 12 only, let's say you have only 12%, right? How many ways you can have a different persons having different birthdays? That's just 12 into 11 into so on 11 into 1, right? That's 12 factorial. But if there are n persons, if it is n that is less than 12, right? So you just go back as you can, right? That's why it is 12 minus n plus n minus 1. So if n is 1, you get 12. If n is 2, you get 11, right? And so on. It's just something like NPR, right? NPR or whatever. Have something, these things. Um, I mean, these questions, right? You can see here, you are given month. Same question can be posed as days, and same question can be posed as weeks, right? So what will change? What will change? I mean, if you can solve for days, why should it be difficult for months? 365 becomes 12. That's it. And for weeks, 365 will become 52 or whatever, right? So I'll post this recording. Let me stop the recording. Okay. Okay, stop.